Yes, students, in this video, we are going to discuss problems related in first unit that is based on antenna efficiency, directivity, radiation intensity.
Okay, let us start one problem. This problem. So here the question is an antenna has radiation resistance 73 ohm and loss resistance 7 ohm. And if the power gain is 20, calculate the directivity and efficiency of an antenna. So what is the given data? Radiation resistance is equal to 73 ohm and R loss is equal to 7. So you can easily calculate the efficiency. The efficiency data is equal to R radiated by R radiated plus R loss. Therefore, 73 by 73 plus C. 7 that is equal to 80 ohms. So the efficiency is equal to 0. That is the other thing they have asked. They have asked to calculate the directivity. Okay. So we have derived the relationship between directivity and power gain. What is the relationship between directivity and power gain? Directivity D is equal to power gain by eta. Okay, so therefore, what is the value of directivity? The value of directivity is 20. What is the value of efficiency? That is 2.9125. Therefore, the directivity is equal to 21.9. Okay, so this is how we will calculate the directivity. This is how you calculate the directivity. Okay, so the same thing directivity in dB. The formula is 10 based on directivity that is 10 based on 21.9. So dB in dB is equal to 13.4. Okay, so this is a simple problem. So very important problem. Next, another question, let us consider. So sometimes they may give directly the directivity gain and everything. Sometimes they make you power gain. Okay, they make you power gain. In that case also you can calculate the directivity, or sometimes they will do the directivity. From that also you can calculate the power gain. Okay, let us take another problem. Okay, so for a source of radiation intensity is equal to sin square theta. Okay. Find directivity. Okay, so this is the question. So what is the thing you want to calculate? You want to calculate the directivity. If you know the direct relation, directivity is equal to U max by U average. So this is the formula for directivity in terms of radiation intensity. Okay, so what is the given data they have given? U of theta comma phi is equal to sin square theta. Okay, so from this expression, what is the maximum value? U max means this is the U of theta comma phi is equal to sin square theta. So what is the value of maximum value? So in maximum value, so sin square theta means the value we have at the maximum value is 1. So on that expression, the value of max is equal to 1. Okay. What is the thing I want to calculate? U average. Okay. So what is the expression for U average? So you have derived that the expression for U average is equal to P radiated by 4. P radiated by 4 pi. Okay. So what is the expression for P radiated? The expression for what is the expression for P radiated? The expression for P radiated is equal to double integral of pi is from 0 to 2 pi, theta is from 0 to pi, P of theta comma pi into R square sin theta d theta d. But what is the value of R square into P of uh, P of theta comma pi? It is nothing but U of theta comma phi. Okay, so that is nothing but U of theta comma phi. So therefore, what is the value in the place of R square into P of theta comma phi? I can simply substitute sin square theta, which is nothing but therefore P radiated is equal to double integral of, so pi is range from 0 to 2 pi, theta is range from 0 to pi. In the place of p of theta comma pi, theta comma pi into r square, I can replace with u of theta comma pi. What is the value of u of theta comma pi? They have given in the problem sin square theta. Sin square theta into sin theta into uh, sin theta into d theta d phi. Okay. So therefore, p radiated is equal to pi is equal to 0 to 2 pi. Theta is equal to 0 to pi sin cube theta d theta d phi. Okay. So since here no pi term is there, okay, so we'll get 2 pi. Okay, so this can be written as 2 pi. So 2 pi into, I can write it as 0 to pi as 2 into 0 to pi by 2, 0 to pi by 2 sin cube theta into d theta. So that is nothing but P radiated is equal to P radiated is equal to 4 pi into integration of 0 to pi by 2 sin cube theta into d theta. Okay, so there is a formula for anything when 0 to pi by 2 sin power n theta. Okay, so the expression in the n theta into d theta, the solutions are n minus 1 by n when n is odd. N is odd. The same expression n minus 1 by n to pi by 2 then n is even. So from this expression, what is the value of n? N is equal to 3, which is odd. Okay. What is the expression for P radiated? P radiated is equal to 4 pi into integration of sin cube n theta. Okay, so it is nothing but n minus 1 by n. So it is p minus 1 by 3. So it is, so 4 pi to, that is 3 minus 1 to 8 pi by 3. So this is the formula for P radiated. This is the formula for P radiated. Now we want to substitute here. Okay. So this is the formula for T. U max value is 1. So in the place of U average formula is P radiated by 4 pi. Okay, P radiated by 4 pi. Therefore, directivity is equal to what is the value of U max? U max is 1 by what is the value of U average? U average means P radiated by 4 pi. What is the value of P radiated? The value of P radiated is, the value of P radiated is 8 pi by 3. 8 pi by 3. Okay, so I can substitute here. Okay, so the value of P radiated is, I can substitute it as 8 pi by 3 by 4 pi. Okay, so directivity getting is 3 by 2, that is equal to 1. Therefore, directivity is equal to 1.5. Directivity in dB is equal to 10 log base 10 d. That is 1. So it is equal to 1.76. Okay, so this is another problem. Okay. Let us solve another problem. The given data is what is the maximum effective aperture area for a beam antenna having half power beamwidth on 30 degrees and 25 degrees in perpendicular plane intersecting the beam axis. Projecting the beam axis. Assume minor lobes are small and they can be neglected. They can be okay. So let us see here how to solve this problem. Okay. So what is the given data? Theta half power beam with the degrees. They have given it as 30 degrees. 5 degrees in half power beam with they have given it as 25 degrees. Okay. So they have asked to calculate effective area. So effective area A. Okay. So effective area they want to calculate. Okay, so there is no relationship between effective area and this given data. Okay, so but you know the relationship between effective area and directivity. Okay, you know the relationship between effective area and directivity. So what is the relation? D is equal to, we are having that relation 4 pi AE by lambda square. So once if you find the calculate the D, directivity, then we can calculate the effective aperture area. So what is the formula for the D in terms of theta, half power beam within theta direction and half power beam within phi direction? So it is 41293 degrees by theta in half power beam with the direction degrees and phi in half power beam with the direction. So on this you can calculate 41293 by 30 into 25 is 55.057. Okay, so the value of directivity is 55.057. Okay. Once you obtain the directivity, once you obtain the value of directivity is equal to 55.057. So we know the relationship D is equal to 4 pi AE by lambda square. On this, what is the expression for A? A is equal to D into lambda square by 4 pi. Therefore, effective aperture area, effective aperture area A is equal to, the value of D is 55.057 into lambda square by 4 pi. Therefore, effective aperture area is 4.37 lambda square. The units are effective aperture area is meters. So this is how you can calculate effective aperture area. This is how you can calculate the effective aperture area. So let us calculate, for example, there is an other problem. Calculate effective aperture area. Effective aperture area of Hertzian dipole, monopole, and half wave dipole. Half wave dipole. Okay. So this is the gate width. I have to calculate aperture area of Hertzian dipole, monopole, and half wave dipole. If the solution is okay. So what is the relationship of we know that directivity is equal to 4 pi AE by lambda square. From this, the expression for AE is equal to D into lambda square by 4 pi. D into lambda square by 4 pi. So you want to come into, you want to know that for a Hertzian dipole, D is equal to 1.5. Similarly, for a half wave dipole, directivity is equal to 1.6. So for a water wave monopole, the directivity is equal to two times of half a dipole, that is 2 into 1.64, it is 3.8. Okay, so these are the things you want to remember. Okay, so therefore effective aperture area for adjacent dipole, so simply substitute d is equal to 1.5 lambda square by 4 pi. Similarly, effective aperture area of dipole, simply substitute 1.64 lambda square by 4 pi. Similarly, effective aperture of quarter wave monopole. Quarter wave, half wave. This is for half wave, but this is for quarter wave monopole. So it is 3.28 into lambda square by 4. So this is how you can calculate effective aperture area of adjacent dipole, monopole, and half wave dipole. But the thing is, you want to remember what is the directivity of adjacent dipole, what is the directivity of half wave dipole, what is the directivity of quarter wave monopole. Okay, so if you remember, you can easily calculate the effective aperture of half wave dipole, effective aperture of half wave dipole, and adjacent dipole, half wave dipole, and quarter wave monopole.